Assalamualaikum warahmatullahi wabarakatuh and good morning. Hello, this is DrRosmaini again. Continuing for lecture on chapter 4 on Management Information System class. And this chapter titling the IT infrastructure, hardware and software. Okay, I have uploaded to the Modo platform on this chapter 4 PowerPoint material and also one more MIS educational video clip on cloud computing. So you may have it accessed later. Okay, let's get started with our business. First of all, let's take a look on our learning objective. In this chapter, I'm supposed to enable you to understand definition of IT infrastructure and also describing those its component that make the IT infrastructure works. I am also supposed to be able to make you identify and describe the stages and technology drivers in IT infrastructure evolution from the olden days in 1930s and 40s up to this new millennium year 2000. Okay, you should be able to access contemporary computer hardware platform trends as far as what hardware makes it the IT infrastructure performing. So you should be able also to pretty much assess the computer temporary software, its platform and its trends of development. And you should be able to somehow evaluate the challenges, the difficulties, the obstacle, and the success factor in managing IT infrastructure, including its management solution. Okay, so let's take a look on as simple as IT device like your smartphone. This smartphone is it merely phone, or is it a computer, or is it an appliance of computing device? So it depends on how you take a look on this simple device. This could be a computer, and this could be also basically a comprehensive computing devices, I would say. Okay, these are what this chapter is all about. Okay, prior going through into the contents of the IT infrastructure, hardware and software, let's do some reflection on the existing IT infrastructure that has very much influenced our daily life, the quality of life, and the way we live nowadays. Okay, let's take a look on Grab uh, car uh, chartering system. Okay, or in other words, Grab car. Okay, I believe many of you or most of you may have already experienced taking a Grab car. Okay, so how come a Grab car could be so successful and dominant until it is almost replacing the traditional or taxi in our country? So what makes this enable, or what makes this possible? This has been made possible partly or mostly is due to the IT infrastructure and its communication broadband speed. So Grab is a successful company in the Southeast Asia and also in many parts of the world. And Grab was actually founded in Malaysia by Anthony Tan. So subsequently, they moved the headquarters to Singapore, and now it is a Singapore-based company. Say, what makes Grab success? I would say it is predominantly influenced by the reliable IT system, strong computing power, and also communication broadband, which is performing excellently well. And on overall Grab company, it employs about 2,000 workers in the whole region of Southeast Asia, including Malaysia, Singapore, Thailand, Philippines, Indonesia, and you name it. And it uses advanced computing technique, for example, cloud computing, data warehousing, smart networking, and it also includes using Amazon's Redshift technology, and also Elastic Cache as far as data cloud storage technology is concerned. So, in order to enable Grab to be successful, I would say, chartered car company, so there are many aspects of IT that has been incorporated. And of course, recently to enable easy payment, so Grab has signed a memorandum of understanding with Lipo Group for e-payment platform or e-platform for electronic payment technology. So it has made even easier for customer would make the payment currently by integrating the e-payment platform by using a LiPo system, right? So those are part of the reflection of how does technology infrastructure has very much influenced our lifestyle, our quality of life. I would say it is significantly positive and moving into the right direction. Okay, bottom line is, what does infrastructure in IT mean, and what are they consisting of? Basically, IT infrastructure is made of a set of physical devices, for example, a server, a router, switches, terminal, or perhaps some mainframe computer, and that integrate together with software, and it operates in such an integrated manner so that it can deliver the whole performance of IT infrastructure. So on the firm wide services that being served by IT infrastructure, it could be a computing service platform, telecommunication service like Skype, uh, Google Meet. Those are telecommunication services. Data management like a database by using SQL databases, because every time you access a website, for example, like Shopee or Amazon, you are using a database management service. Application software, you name it. So there must be application software that you are using, for example, Microsoft, or for example, Google. So those are apps, application software services available within the IT infrastructure. Physical facilities management, like the IT room or IT, I would say, center, its IT management, the training, the education, and other complementing services. So I would say those are making up for good IT infrastructure. So, and that enable us to live comfortably nowadays in the era of Industrial Revolution 4.0 and the Internet era. Okay, let's take a look at, say, e-commerce platform online like Amazon. So Amazon has been a very successful company as far as online e-commerce platform. Okay, together with, for example, Alibaba, Shopee, Lazada, and so on. You name it, right? So as the case for Amazon, it is supported by many data centers, and at their data centers there are many servers, and inside that server there are many processors or microprocessor, right? So as far as Amazon is concerned, their data centers is basically totaling up about 350,000 processors. There are there are a lot of number of processors around the world in their data centers. Okay, so Amazon strive to be a world-class company as far as serving its customer. So that is their IT services infrastructure. So they try to attain a good customer services, supplier services, and also serving enterprises in their cloud computing platform. So by that, they must have an excellent business strategy. So they must be at the forefront of computing, at the forefront of perhaps in as far as investment in the IT infrastructure, network, server, uh, communication band, and so on. So Amazon has a very strategic IT approach, all right? So you must have a good vision and good strategy to champion this IT infrastructure. For example, Amazon Web Services, AWS, that hosted many of cloud computing platform nowadays with many business subscription. Of course, IT is the hardware and the software itself that drive the Amazon online service to be successful. So this is how they are very much interrelated. In order to have excellent service, it must be supported by the infrastructure and the services application itself, supported by appropriate business technology embedded with excellent IT strategy in terms of vision and mission, and incorporated state-of-the-art or latest IT technology into your whole IT infrastructure. Okay, let's take a look on how it looked like IT infrastructure in the olden days. Perhaps we could say after the World War II, 1945, or slightly later, 1950s, world of communication has become very much more developed or modern. For example, in the 1950s, IBM, International Business Machine, was among the first who developed a mainframe, which is an independent computer, which in those days was normally used at banks, marketing company, normally big companies. So mainframe, it looks like this, okay, in this black and white picture. And in those olden days, data or information, they are kept in the tapes like this. This is a tapes. Instead of nowadays, you back it up in the hard disk or even bigger storage in the data center. So these 15 and 60s are the decades in which the majority of computer operation was basically run under a mainframe. Mainframe is well-known mainframes manufacturer in those days was IBM and DEC, Digital Equipment Corporation. Okay. Moving on into the next decade in the 80s, we would say that if in the 60s, computers were normally used by big companies. So this era in the 80s, they start personalizing computer towards for personal usage for students, for professors, for individuals. So in 1981, IBM personal computer was introduced in the market. So it is basically a standalone computer with a single processor and with its own monitor, and you can run application like WordStar or WordPerfect. In those days, those are the popular, I would say, microprocessor replacing by Microsoft Word nowadays. So these are the era for personal computing in which individual can have their own computer. Moving on into the subsequent years in 1980s, computers start to be based on the network called client server, so in which companies, normally organization, they have a server, and this server is basically connected to many terminals for the employees to be used, so that employees within the companies or employees within the organization can have their own terminal, and they are connected to server to access the needed software or application. Okay, there you go. So in the recent decades, in 1990s, for example, okay, the computing era has been moved towards the enterprise level. Enterprise level means that at this company or organizational level, for example, by having ERP system, enterprise resource planning, or MRP, material planning application. So it goes to the enterprise level, okay, in which this enterprise has their own server and it is connected to the internet, and that internet connection are connected to the other branch of company or the other subsidiary, so that they can work as a integrated enterprise computing network. Okay, moving on into the new millennium, year 2000, and in the today's technology development, we are moving very much toward resource sharing, okay, in the form of like cloud computing and mobile computing. Cloud computing, like in the form of Gmail or G Drive, those are an example of cloud computing network. Mobile computing, if you're using like Google Map or Waze, those are mobile computing application, which is very much fastly growing in current new millennium. Okay, what are the most recognizable 10 brands in the world? Okay, for example, by this survey, it is suggesting that Nike, Apple, Google, Amazon are among the top brands that easily recognizable around the world, okay, including Microsoft. So those are very much big company that apply or invest heavily in their IT system, their infrastructure network, and also cloud computing base. So as such, they can become a very noticeable brand in the world as a world-class brand. Okay, just now I have taken a look, I would like a summary on the development of the IT infrastructure in the 1960s. It is basically this era in which all terminal are connected to a mainframe or mini computer. In the 80s, it is very much based on these terminals by all employees use their terminal and connected to a server. And in the 80s, very much our server terminal are connected into a local area network, whether it is wire-based or Bluetooth connected. This is for the purpose of shared resources in which people could share, for example, one software like Autodesk, and it can be used by architects and structural engineers if it is parked at the server, and many related employees could use the same software. In the fourth era, very much in this current present time, very much we are in this kind of network in which we are interconnected by server and internet, right? And all the employee terminal, either mobile or PC or notebook, connected to the internet through the company's network, so that you can easily access a company application from anywhere in the world and anytime if you're working globally. So Oracle database is one of the a good world-class database that many worldwide company using it. So, and nowadays in the latest era, which is based on cloud computing, we are very much interconnected in terms of resources by through the cloud platform. Okay, for example, Google Drive or Amazon Web Services platform. Those are the current IT infrastructure stage that we are having right now. Okay, at the single layer architecture of IT infrastructure, we have something like this. This is the most common layer that many company has. So, for example, we uh, take a look in the case of Amazon.com. So, Amazon.com is basically having is a very large data center which are housing their web server, right? And this web server is, of course, connected into the internet. Internet is basically a network of networks of computers, and it links to client with a PC, terminal, mobile. So these are client, which is you and me. So in order to purchase a product at Amazon, like books, so you got to access to the your device, and then access to the World Wide Web internet, and then it goes to Amazon web server, and later it goes to perhaps purchasing their I would say books, and later it will access to the sales, accounting, and also have payment records and interacting with the database. And normally database is hosted by Oracle or SAP, and it interact with your purchase, and subsequently you decided what item to purchase and make the payment, and Amazon makes the arrangement for the product to be sent logistically to your address. So this is what they call a multi-tiered client server network, or N-tier. So this is N-tier because this is tier 1, tier 2, tier 3, tier 4, and tier 5. This is 5-tier client server network, okay, as highlighted in the case of Amazon. Okay, so in IT infrastructure, basically what governs the development and the evolution of IT infrastructure was mooted by Moore's law. Moore is a scientist who, I would say, one of the pioneer inventor of microprocessor. So at Intel, so Moore's law says that every 1 year and a half, computing power doubles. Right? For example, from 40 gig, okay, or becoming 80 gig, I would say that is as of storage. Computing power doubles every 1 year and a half, or 18 months. Okay, because the number of transistors that is etched or embedded into the microprocessor also become bigger and bigger. So if now the speed is, for example, perhaps 20 gigahertz, okay, it will easily double to 40 gigahertz by the next year, by the next 18 months. So law of mass digital storage, we could see that our storage from year to year become bigger and bigger, right? If you have 1 terabyte of storage, it is easily will become 2 terabyte in the next 1 or 2 years. Okay, so those are the growth of evolution of computing power and storage. Okay, this is a reflection of how I would say older computer it was look like. So this is a computer basically named ENIAC. Okay, ENIAC was a computer developed in the United States, and in the old days they have this connecting cable, so mostly connected by human, by these ladies. So this computer perhaps is as good as your 8088 processor, but the size is as big as this room. Okay, imagine the difference with your computer nowadays on your palm of your hand in the name of smartphone. That is basically computer. Okay, Moore's law and microprocessor performance. If you take a look in the olden days, in the 70s and then 80s, 90s, and the new millennium, basically the number of transistor that they are packing in the past, I would say 30 or 40 years, in those olden days, only this limited number of transistor, they can pack it up into a microprocessor. But nowadays, you can pack it up as much as 2.6 billion transistor into this kind of single microprocessor, right? And your processing power by the unit of MIPS, milli instruction per second, has grown up to 128,000 milli instruction per second, right? So it has grown so big, and it has embed so many transistors into this single processor. The faster the microprocessor, the more transistors that you need to be embedded inside it. Okay, so this is an physical example of a single transistor, right? And this is the electric schematic diagram of transistor. This one transistor, and you could imagine 2.6 billion such transistor embedded into this single small microprocessor, perhaps as big as your thumb. Okay. Okay, actually, computer works with the bit system. It is working with one or zeros. Okay, it is either a current high or current of high or low. High, 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 low, high, low. These eight bits is making up one byte, right? And computer works based on one and zeros, which is known as ASCII code. Okay, it is a computer numbering system which is based on binary, which is 1 and 0. However, human work with a number system we call decimal, which is 10, 11, 65, and so on. So from human numbering system, we have to convert into this binary 1 and 0 numbering system in order to enable computer to work for human. Okay. What makes computer fast? It is basically because they can process information at the speed of light, right? So that is what is meant by why computer can calculate so fast. Okay, it is just alternating between 1 and 0, sequence of 1 and 0. Okay. This is just a glimpse of ASCII table. So by human number, it is 0, 1, 2, 3, 4, 5, 6. But by computer number, it goes by this 1, 1, 1, 1, 1, 1, 0, 0, 0. And for example, number 60, if a human call it 6, 60, 60, computer will calculate as 1, 1, 1, 1, 0, 0. Okay, that is the computer number system in order for them to calculate. But for human, we work on decimal. Okay, from time to time, from years to years, from decade to decade, from the olden days in 1960s and up to current millennium. So the cost of chip, the cost of semiconductor like this processor has been decreasing significantly. Okay, so I would say nowadays microprocessor or chips could be said at a very, very low cost in comparison to perhaps 50 or 60 years ago. So the cost has been decreasing significantly. And the cost of data storage also has become cheap, right? Because if I could remember when I studied in the United States in 1997, I had bought a hard disk. It is just 40 meg. Okay, it will cost me around 100 US dollar. Okay, but nowadays in the new millennium, if you buy a 900 gig hard disk, it just costs you perhaps just 50 US dollar or ringgit Malaysia 180. So from 450 to 180, that is almost a 3 time cost reduction within just about maybe 25 or 30 years. Okay, this has been about 30 minutes. I think let's take a break, half lecture of part one here. So this is about 28 minutes lecture already. So we take a short break and we will continue after that. So see you soon. We just take a short break, 10 minutes. Thank you.